the 17th on this for your test. All right, chapter 4, we're moving into the atom. So you should be able to open your packet up to the very first page after the calendar and find the notes. Okay. The atom is the smallest part of the element that retains the properties of the element. There are parts of the element or the atom that are smaller, but you're not gonna be able to go, oh, that electron, that's sodium. You can't do that. So this is what retains the properties of the element. Electrons, protons, and neutrons then make that up. There are universally accepted abbreviations for these. If you go on and take college chem, if you go on to take AP, you could actually use these on the AP exam. So you will see these used, and I will start using them from here on out. So you need to kind of get used to what these symbols are. Electron then is a negative. Proton is a positive with a little p. And the neutron is a little n with a 0. And these indicate the charge of each of these particles. So an electron is a negative charge, a proton is a positive charge, and a neutron does not have a charge. Okay. So moving on to the electron, this is where we're going to spend the majority of the majority of the year really is spent on the electron, because it's truly the electron that ends up determining the way that these atoms interact. So an electron is the lightest particle in the atom. It has a negative charge, and it's found surrounded by the nucleus in what's called an electron cloud. Any questions on that? Okay. The nucleus then is the center of the atom. It's surrounded by this electron cloud. It's going to have your protons and your neutrons in it, and it has the majority of the mass. So the center of your atom is your nucleus, and then you have these electron levels that surround that. But the majority of the mass of the atom is all contained right within that nucleus. So again, here are the abbreviations for these. Here are the locations. Here are the charges. This mass is very small. And I want you to kind of keep that in mind, because when we start talking about atomic mass, we don't actually factor in the number of electrons. It would be kind of like if I got on a scale and weighed myself, okay, and then I lost an eyelash, would my mass change at all? Technically, yes, but you would never see it recorded on the scale. Does that make sense? So yes, you're right as far as the scale. I would have lost a little bit, but it would be so insignificant that it would never register on the scale. Does that make sense? That's the way an electron is for the mass. All right, so let's look at our periodic table. If we had our periodic table and we had molybdenum on there, it's number 42. That tells us our atomic number. The atomic number is the number of protons. It is sometimes abbreviated with a capital Z. No idea why. Just the way it is. The atomic mass then is an average mass based, it's based on the number of isotopes and how many are out there. And we're going to talk about how to calculate that in a couple minutes. So atomic number is the number of protons. That's this guy. So here, if we wanted to know the proton number for any of these elements, we would happen to look at the atomic number, and that would give it to us. That atomic number does not change. We cannot change that number unless we go through some sort of nuclear reaction. The number of electrons then equals the proton number, because when we have an atom, our atom is neutral because we have the same number of pluses as we do minuses. So for here, down here, our electrons, if we had 19, how many protons would we have? 19, because we need to have a zero charge. So if I have 19 positives and 19 negatives, that equals out to 0. Okay. If we look up number 19 on our periodic table, we see that number 19 is number 19 on my periodic table. Potassium. And potassium's atomic number is 19 because that is its number of protons. All right, number 35 for the proton number. How many electrons am I going to have? 35. What's its atomic number? 35. What element is it? Bromine. Okay. Neon. What is neon's atomic number? How many protons does it have? How many electrons? Hard math? Easy? You do that? All right. Isotopes then. I alluded to that name a few minutes ago when I was talking about average atomic mass. An isotope contains a different number of neutrons than protons. So if you want to think about it as a mathematical kind of thing, that's what it would look like. Each isotope is going to have a different mass number. The mass number is the number of protons and neutrons. So if I want to figure out mass number, what do I have to do? If it's the number of protons and neutrons, how do I figure out the mass number? Add them up. Yep. So protons plus neutrons gives me my mass number. This is often expressed at the end of an element symbol. For example, this would be carbon 12. This would be carbon 14. So carbon 12, we know it's going to have 6 protons. How do we know it has 6 protons? Yeah, it's carbon. That is the definition. Okay, the definition of an element is defined, its identity is defined by how many protons it has. So if this has to be 6, if we subtract from 12, then we have to have 6 neutrons. If this is 14, well, 6 of them have to be protons because otherwise it wouldn't be carbon. Okay, so then the other 8 have to be neutrons. Does that make sense? All right. This is an isotopic symbol. So for isotopes or anything really, this is what that looks like. Your A value then is your atomic mass. Your Z is your atomic number. And then the C here is your charge. And we'll get into that in just a minute. If it doesn't have a charge, we don't write a 0 up here. We just leave the charge off. Okay. So this was what fluorine would look like. So how many neutrons would this fluorine atom have? Okay, what is my mass number? My mass number is protons and neutrons. What is this number right here? Atomic number, which is the number of protons. This is the number of what? Mass, well, protons and neutrons. So how many neutrons do I have? 10. 19 minus 9 is 10. How many electrons do I have? Yep. What's my charge? My charge is 0 because there's nothing written there. So that means that I have the same number of electrons as I have protons. So that would be 9. All right. When an atom loses an electron, it becomes positively charged. It's called a cation. Meow. No. Nobody thinks that's cute. No. It's a cation. Okay. So think of that as a plus sign here in the middle of the word if you need to, if that helps you. They are positively charged. And that means that we have a greater number of protons than we have electrons. We have more positives than we have negatives. If we have an atom. Now we don't have an atom anymore, we have a cation. So for an atom, our protons equal our electrons. For a cation, our positives, our protons are going to be greater than our electrons. We won't have an atom anymore. We'll have what's called an ion, and specifically in this case, you would have a cation. Because most of the things on this side of the periodic table are going to lose an electron. And we're going to talk about that when we get into chapter 7. We can also have it where they gain an electron. So in this case, you're going to have fewer positives than you would have negatives. So that's an anion. So a cation, this is an anion. A cation, you're going to have more positives than you have negatives. And an atom, they will be equal to one another. And what's this called? More vocabulary? Isotope, good. Okay. So you've had, essentially, I would guess, you've probably had 3 vocabulary words that you've never really heard of before. Okay. Isotope, and then cation and anion. I'm guessing you've heard of an atom before. And you've heard of protons, neutrons, and electrons before. Okay. But these are going to be 3 new words for you to kind of bring in. All right, let's figure out the number of electrons in this ion. If this has a +2 charge, how many electrons would sulfur normally have if it wasn't an ion? Okay, so its atomic number is 16. Now, -2, does that mean that we got more electrons or we got rid of electrons? What charge is an electron? Negative charge. So if this became more negative, did it gain electrons or did it lose them? Gained. And how many did it gain? 2. So plus 2, that's going to be 18 electrons. So it normally has 16. It has gained 2 electrons. So it now has 18 electrons. All right, boron. How many does boron normally have if it's an atom? 5. This is a positive charge. So has it gained electrons, negatively charged electrons, or has it lost them? Lost. So what do I need to do to my total number of electrons? Minus 3. So how many electrons do I have? 2 electrons. Fluorine normally has 9. What happened here? It gained 1 electron. So now it has 10 electrons. This is where you have to think through it, okay? Because this is a negative value, but yet I'm adding here. And so why is that? Well, because these are negative charges, I'm adding negative charges up. The other way you could do this is to think of this as, oh, there we go. You could think of this as a -9 and a -1, and you would come up with a -10 electrons. But then you need to remember that you're actually, gaining electrons. So that's the only issue with that. If you need to kind of get your brain wrapped around it that way. Okay, does that make sense? These are negatively charged, so you've got to be careful with that charge number. All right, see if you can work through these couple problems. Work them out with the person next to you. Does everybody? Autumn doesn't have anybody. Looks like Hayden. So you guys, Hayden and Kennedy, you guys may have to buddy up with somebody in front or behind you. Malachi, do you know how he knows it? He looked on the periodic table and he found 15.
Oh no, we have more. Okay, we have more. Yeah, right. I thought that was body actually. I think a water bottle. Are we about to? Yeah.
All right, how did that go? You okay with these? Anybody need more time on that slide? Anything that doesn't make sense to you? We need to talk it through. Good? Everybody cool? See how we got it? Good. All right, next one. I want you to determine the protons, neutrons, and electrons in each of these. Remember, this number here is the number of what? What added together gives me this number? Protons and neutrons, okay? So that added together gives me that value. Okay, see if you can, and then this is your charge value up here in the corner. So see if you can work through that with your seat partner. Oh, this is senior homecoming. I don't have any seniors in here, do I? Yeah. I don't have any seniors that dressed up for homecoming, though. You didn't dress up for homecoming today? No. It's supposed to be soccer mom, so, you know, that's good enough, soccer mom. You know about the senior dress-up days? Did they tell you about those? Oh, you're not a senior? Oh, I thought you were. All right, then. Get rid of that, then.
Yes. Just looking at it.
Yep.
For the positive symbol on NA, what do we do with that?
It's +1.
Okay, that's what.
All right, I got the first two up there. Or the first and third, depending on how you did these.
No, that day. Oh, okay.
Hi.
Right.
Yay or nay? Easy enough? You guys can handle these? What you struggling with? What do you not understand? Oh, yeah, just lay that on my counter over here, if you don't mind. Sorry. Thanks for taking it off. Need somebody to do my housekeeping around here, I tell you. Can't keep up with everything. All right, y'all. Your homework then is 4-1 in your packet. It's a ways back. You may want to get like a paper clip and like paper clip the notes so that it's easy to find. So we had a lot of notes coming up at us over the next little bit.